All right, so today I'm going to show you how to SSH into multiple machines and get the output from a command run on all the machines at once. There are a bunch of commands out there that do this, and they all have their own little quirks, so I decided to throw another one in the mix, all right? So I wrote my own command, and that's what we're going to use today. It's called sshp for SSH Parallel, and we'll go ahead and git clone this. You can run this on your machine. Let's cd into sshp, and it is a C program, so all we have to do is run make, and it will go through and it will compile it, and there we go. And now we have a new sshp binary. We can verify that it works with -v to get the version number, and then you can also run -h to get the help message. There's a long help message, there's a man page included with it, there's a lot of stuff with it, there's a ton of stuff going on here, but I'll show you some quick, cool little things we can do with this, all right? So let's take a look. What should we do first? Well, we can make a host list. So let's do host.txt, and in here we can put a list of the hosts that we want to SSH into. We can put comments up here, and it doesn't really matter. We can put new lines, it doesn't matter, but we can put a list of hosts separated by new lines. So what host are we going to use? Arbiter.rapture.com, void.rapture.com, and vault.rapture.com. These are hosts that exist on my local network. So how do we get into them? Well, we can do sshp-f hosts.txt, and we can verify this works by just echoing hi. So what happened? It SSH into all three hosts at the same time. There's a max parallel of 50 hosts at the same time, and you can see that it ran hi across the board, and it went in the order that we specified in the host.txt. Now you might notice it doesn't quite match the order, so what's going on? That's because they're all executing in parallel. We started them in order, but some finished before other ones. So we can actually put -m1 here and limit the max jobs to 1, and then it will go in order and it will do it one by one and wait for the one above it to finish before the other one gets started. So what else can we do? Notice that the output is green. What if we run a bad command, a command that doesn't exist? Now we have red output. How nice. Standard out is green, standard error is red. I wanted a way to differentiate them, so I added that color coding to it. What else can we do? This command is super useful for if you have, let's say, a log file across a bunch of machines. You can tail -f it. I don't have a log file on the other machine, so we'll just do my bash RC. You could run this, and then as you can see, it's hanging, it's waiting for any sort of output on any of the commands or any of the host names, and you can see that it puts the host name at the beginning of the line. This is super useful. You can see what host had data. So let's Control C this, and it will go through and it will close all the SSH connections for us. Awesome. What else can we do? Well, we can group output together. So what I mean by this is let's look at the first 3 lines of my bash RC with the -g argument. So what does the -g argument does? It doesn't put the host name in front of each line, it puts it at the beginning and then shows the output as it comes in, so it groups the output together. This is a nice way of seeing data. You can combine this with, let's say, -m1, and then you can go through a list of hosts and then just get the output on a per host basis. Really useful. So what are some other things we can do? Well, one thing we can do is we can use the -j mode. Just like we have the group mode, this is the join mode. This one is my favorite. It's super useful because it will join the output together. So what does that mean? Well, let's run hi across 3 machines. It'll go to all 3 machines, run it, and tell you there was one unique result. So all 3 hosts had the result hi. So this is useful to find discrepancies. So I can run uname, and we can see that there were 2 unique results. Arbiter and Vault returned SunOS, but Void returned Linux. So 2 of these machines are running a Lumos, and 1 of them is running Linux. So we can see this really quickly using sshp or sshp-j. The last thing is, be careful of this, there can be side effects. So if I run a command like true that doesn't print anything, it didn't print anything, but it still logged into each host and ran it. How do we verify this? -e. We can see exit codes. So if we rerun this, you can see it exited with code 0 and it tells you how long it took. We can verify this by running false instead, and you can see that it'll say exited with 1, and a bonus is the actual output of this command will be 1 because one of the hosts failed. So yeah, there you go. That's a program I wrote in C called sshp.